looking at general solutions to trig equations, just having a quick look at the extension 1 formula sheet. We've got the sums and differences of angles there on the left. Then we've got the T formula here. And then underneath that we have the general solutions. So if we can just write these out, please, the general solution of trig equations on the formula sheet. Now, what you need to realize is that this sine to the -1 of A, this bit, and that bit, and that bit, we've got what it really should say is if at the beginning. So if sine theta equals A, don't you normally do that theta is the invert, like shift sign, to work out sine of an angle is a number, A or whatever, then the angle is shift sign of A. So this shift sign of A, that's actually what the acute angle is. So that's the acute angle, theta, is that shift sign of A. That's what it is. So that bit that's circled there is your acute angle theta. So if cos of an angle is A, then isn't the angle shift cos of A? Isn't that how you do it on your calculator? So acute angle A is so this shift cos of A is your acute angle theta, is shift cos of A. That's what that is. Now last year when we did it in prelim, see this could actually just be replaced with alpha if I let the acute angle be alpha. So acute angle theta is tan to the -1 of A. So that whole expression there is just the acute angle. Now you'll see it when we do some questions. All right? When we do some questions, I'll point it out to you. So when we looked at prelim, this is how you saw the formula. You said theta is 180n plus -1 to the power of n times alpha, where alpha was the acute angle. So in prelim, we saw it like this, that if sine theta is, I think it was like this, is alpha, then theta is 180n plus -1 to the power of n alpha. No, not alpha. Sorry. No. Sine theta equals sine alpha. So that A is sine of alpha is A. All right, so the way it's written in your textbook is as follows. If sine theta equals sine alpha, see alpha is the acute angle, then theta, this is the general solution for all the thetas. Then theta is 180n plus -1 to the power of n times the acute angle. All right, that's how you learnt it in prelim. Then it was if cos theta equals cos alpha, then theta is, now 2 pi n is 360n plus or minus alpha. That's how you encountered this in the prelim course. So in the prelim course, this is how we encountered it. And if tan theta is tan alpha, but it's not written on the formula sheet like that. It's if tan theta is A. That's how they write it now. So if tan theta is tan alpha, then theta is, you know how we've got pi n, that's 180n plus alpha. Is it plus or minus? Plus alpha. All right, so sometimes that alpha is going to be positive, sometimes it's going to be negative, depending on the quadrant anyway. All right, so this is how we encountered it in the prelim course. However, this is how it's written on your formula sheet. And that's how you'll see it in your textbook. All right, so let's look at some examples. We know that that's how we looked at it in the prelim course, but we're HSC course now. So it says if cos of theta is A, then we're going to have to work out what cos of what, girls, is √3 on 2. Cos of what? Cos of 30 or cos of 60? Cos of 30. Yep. So we go, x is acute angle. So we need the acute angle first. So acute angle x first is what? We know it's 30, which is pi on 6. And so therefore, my general solution, so we're asked to find the general solution for all these. Find the general solution. Okay? Every possible solution is the general solution. So the formula for general solution is theta, or x in this case, x equals 2n pi, or 2 pi n. I like to write it as 2 pi n actually. Plus or minus the acute angle. What's the acute angle? Anyone? Pi on 6. Okay? So you can write it as 2 pi n or 2n pi, that's fine. Okay? Now, that's your simplest type. Okay? Cos of x is root 3 on 2. Now, this one is always a tricky one. The reason is, cos of x is, now you're supposed to find the acute angle. So when you're working out this cos to the minus 1 of a, it's got to be the acute angle. Now, sometimes that acute angle is in quadrant 1 and sometimes it's in quadrant 4, depending on the question. Now, cos of x is root 3 on 2 means cos of x is positive. The smallest acute angle would be quadrant 1. You know how cos is positive in quadrants 1 and 4? Quadrant 1 is the quadrant we use, okay? But in this question here, cos of x is negative. When is cos x negative? In quadrants 2 and 3. So there's no acute angle in this case, okay? So when cos of x is negative, you don't have an acute angle. Your smallest angle in this case is the quadrant 2 angle. So yes, we know, so I'm actually going to write what the acute angle is, first. Cos of what is a half? Cos of 60, which is pi on 3, but we don't use that. We must use, but it's negative. So we've got, you must use quadrant 2, because there is no, cos of pi on 3 is not negative, so you can't use it. So you must use quadrant 2 when cos is negative. So quadrant 2 is pi minus pi on 3. So the angle you're going to use is pi minus pi on 3, which is 2 pi on 3. So I'm going to draw it here. You've got to use quadrant 2. Yes, I know the acute angle is pi on 3, but cos is negative in quadrants 2 and 3. Which of those two quadrants is what you would consider to be smaller? It's quadrant 2. So our acute angle in this case is 2 pi on 3, not pi on 3. This only happens when cos is negative. So let's keep going. So therefore, when you're using the cos, you've got that x is 2 pi n plus or minus, you must use the 2 pi on 3. Okay? I know that one's a bit weird. The cos is negative will be like that. We've also got to look at the ones where sine and tan are negative. When sine and tan are negative, you have to use quadrant 4. Okay? The third example here, sine of 2x is 1 on root 2. So girls, in this case, my acute angle 2x. You say to yourself, sine of what is 1 on root 2? What is it? Sine of 45, that's pi on 4. So therefore, my solution for sine is, now in this case, I've got to do the solution for 2x. So 2x is, I go up to my formula, and it's pi n plus negative 1 to the power of n times my acute angle, which is pi on 4. So if I go up to the formula, it's whatever I've got here is pi n plus negative 1 to the power of n times the acute angle. Now the acute angle belongs to the 2x. Sine of what is 1 on root 2? It's sine of pi on 4. It's sine is positive in quadrants 1 and 2. You use the quadrant 1 angle, the acute angle in this case. So what should I do now to find x? Just divide everything by 2. So it's pi on 2n plus negative 1 to the power of n, pi on, divide this by 2, divide that by 2, I get pi on 8. Next one. So my acute angle that I look at is the x on 2, and I say to myself, sine of what is a half? Sine of what is a half? Sine of 30, which is pi on 6. Quadrant 1 and 2, but you always use the acute angle, so it's quadrant 1. So my formula for the sine general solution is that x on 2 is pi n plus negative 1 to the power of n times my acute angle, which is pi on 6. Now remember, I'm trying to solve for x. I'm trying to find the general solution for x. What do I do? Times everything by 2. So it's 2 pi n plus negative 1 to the power of n times what? 2 pi on 6, which is 2 pi n plus negative 1 to the power of n times pi on 3. Ready? Okay, what's my acute angle 3x? You say to yourself, tan of what is 1 on root 3? Yeah, tan of 30, which is pi on 6. So my solution for tan is whatever's here. 3x equals, isn't it pi n plus alpha, my acute angle, plus pi on 6? Isn't that it? 180n plus, yep. So what do I do now? I divide by 3. So I get pi on 3n plus pi on 18. Now, so first you do your acute angle. Now, we've got to be careful with these ones now that are negative. I don't have a cos negative, sine negative one. All right, yes, you do. So the reason is tan of something is negative is quadrants 2 and 4. Quadrant 2 is a bigger value than the quadrant 4 if you name it in a negative way, the angle in a negative way. So again, here we go. Acute, tan of what is root 3? Tan, acute angle 2x minus 30. We know it's 60, but I need quadrant 2 or 4. So when you've got tan of something is negative or sine of something is negative, you must use quadrant 4. Because it's negative in quadrants 2 and 4, but quadrant 4 we can write as a smaller angle. So it's 60, isn't it, which is pi on 3. But we use quadrant 4, so we call it negative pi on 3. So the angle is going to be negative pi on 3 in quadrant 4. Are you okay with that, and why? Because tan is not negative in quadrant 1, but it is in quadrant 4. So therefore, tan, so I've got 2x minus 30 is, what's the formula? Pi n plus negative 1 to the power of n of my acute angle, which is negative pi on 3. Isn't that the formula for tan? Oh, no, it's not. I made a mistake. That's the sine one. So, sorry, 2x minus 30 is pi n plus negative pi on 3, which is just pi n minus pi on 3. So now what do I have to do, girls? Oh, sorry, I made a mistake in the question. Instead of writing 30, this should be pi on 6. Pi on 6. Can you fix it? And that is pi on 6. Sorry, very messy. In the Year 12 HSC course, everything will be in radians. So the question will be written as follows. Tan of 2x minus pi on 3 is negative pi on 3. So the acute angle of that is pi on 3, but we have to use quadrant 4 because we're using quadrant 2 or 4, but we're using quadrant 4 because that gives us the smallest acute angle written in a negative sense. So therefore, your angle is pi n plus your alpha. So now I've got to add pi on 3 to both sides. So I get 2x is pi n, this is minus pi on 3 there, then plus pi on 3, so you lose it. So 2x is pi on pi times n. So what does x equal? Pi on 2n. In other words, x will be multiples of 90 degrees. When n is 1, you get pi on 2. When n is 2, you get pi. Alright, the next one. Oh, sorry ladies. That was meant to be 30, which is pi on 6. It doesn't matter. It doesn't matter. Let's make this one pi on 6. It doesn't matter. It does. The only difference would have been we would have added pi on 6 and got something different. Girls, that was meant to be pi on 6. That was meant to be pi on 6, but don't worry about it. What are you going to do now? Do you want to change it to pi on 6 or just leave it as pi on 3? Is the girls, pi on 6, pi on 6, pi on 6. That one's a pi on 6. And so this is what? Minus pi on 6. And this is minus pi on 12. Did you fix it? So girls, sorry, that was a pi on 6. So then you'll add pi on 6. You'll get negative pi on, minus pi on 6. And when you divide by 2, you'll get minus pi on 12. Okay? Here's another one. Sorry. What about this one? What do you do? Cos is positive, thank goodness. What do you do? Acute angle x plus pi on 6 is, cos of what is 1 on root 2? Cos of 45, which is pi on 4. Then we write out our cos solution. We've got to be careful with this one. So x plus pi on 6 is equal to, isn't it 2 pi n plus or minus pi on 4? Now you've got to be careful here. So I've got that x is 2 pi n plus or minus pi on 4. Now what do I write? Minus pi on 6. And I break it up as two solutions. I've got 2 pi n plus pi on 6 minus, plus pi on 4 minus pi on 6. Or x is 2 pi n minus pi on 4 minus pi on 6. Do you see how you've got to go plus and then minus? And then we end up with 2 pi n and whatever you're going to get there. That's a quarter minus a sixth. 6 pi minus 4, 2 pi on 24. Is it pi on 12? Plus pi on 12. So it's just a quarter minus a sixth. And this one is 2 pi on n minus 5 pi on 12. Because we make the denominator, it's minus 3 minus 2, yep. So making a common denominator. Just got to be careful with those. Especially with this one, because you've got to go plus pi on 4 minus pi on 6, minus pi on 4 minus pi on 6. All right, the next one. Sorry, I know I'm doing a lot of them. Got to be careful with these ones, the cos, because you've got to do the plus minus and work out the two different ways. What about this one? What quadrant? You know, cos is negative in quadrants 2 and 3, but which quadrant are you going to use? 2. So we say acute angle 2x, cos of what is root 3 on 2? Cos of 30, isn't it? Pi on 6, but you don't use that. The quadrant 2 angle is what we want. So quadrant 2 angle 2x is 5 pi on 6. Because if you sketch it, you've got pi on 6 in quadrant 2. So it's 5 pi on 6. So the quadrant 2 angle 2x, do you know what I mean? So our solution is 2x is 2 pi n plus or minus 5 pi on 6. You should be able to just divide by 2 with this one, no problem. X is pi n plus or minus 5 pi on 12. You've got your two solutions there already. Cos of x on 2 minus pi on 12 is negative a half. You just do it the same. What's your acute angle x on 2 minus pi on 12? Cos of what is a half? Cos of 60? That's pi on 3. But what quadrant do you use? Cos is negative in quadrants 2 and 3. We must use quadrant 2. So your x on your acute, you know what I mean, x on 2 minus pi on 12 has to be pi minus pi on 3, which is 2 pi on 3, because you're using quadrant 2. And now we can write up our solution. So x on 2 minus pi on 12 is 2 pi n plus or minus 2 pi on 3. X on 2 is 2 pi n plus or minus 2 pi on 3 plus pi on 12. And then you've got to break them up. So plus 2 pi on 3 plus pi on 12, what's that? 2/3 plus 1/12. What's 2/3 as 12ths? 8/12 plus 1/12, that's 9/12. So you've got to work them out separately. Are we okay with that? Anyone got it? Well, I'm thinking it's 9 pi on 12. That's 3/4 pi. And this one is 2 pi n. What's that's minus 8 plus 1. Is that minus 7 pi on 12? I'm not finished yet. And then you multiply through by 2. What did you get? 4 pi n plus 6 pi on 2. That's 6 pi on 4 is 3 on 2 pi. And x is, sorry, that's just an x. You're multiplying through by 2. You get 4 pi n minus 14 on 12. What's that? 7 on 6. Is that what we got? So we would have got 6 on 4, which is 3 on 2. And would have got minus 7 pi on 6. Now, the only thing, I didn't do a sign where sign is negative. Sign is negative in quadrants 3 and 4. You would use quadrant 4 for the sign being negative. I should do one of those, actually. I'll do one now. I've done one where sign is negative. So solve sine of 2x is negative 1 on root 2. So acute angle sine is what? Acute angle 2x is? Well, it's pi on 4, but that's a quadrant 1 answer. Sine is negative in quadrants 3 or 4. Which quadrant are you going to choose? Quadrant 4. So you've got to go negative pi on 4. Are we okay with that? So the solution for sine, so therefore 2x is, isn't it pi n plus negative 1 to the power of n times negative pi on 4? So actually what I want to do with this type, I don't know if I had a negative sign yet. See that times negative pi on 4, you really should be bringing, instead of plus negative 1 to the power of n times negative, you put the negative minus there, sorry. You write it like that. So instead of plus a negative, you just go minus here. But you still got the negative 1 to the power of n. Okay, so be careful of that. When you've got the sign rule, the sign one, you plus, and it's negative, instead of having plus and negative, just put the minus there. Now we're going to divide through by 2. And what do you get? Pi on 8. General solution of ones like this. Remember, it's meant to be the acute angle. Sine of what? I'm going to do a little sketch of the sine curve here. Because sine of what is 1? Sine of 90. Or pi on 2. So with this one, your acute angle x, you need a little quick sketch to work out your first angle. Your acute angle x is sine of 90 is 1, so pi on 2. Okay? And then you can just use your formula. So therefore x is pi n plus negative 1 to the power of n times pi on 2. Okay with that? That is x. The next question, sine of x is negative 1. Well, there's your sine curve. What are you going to use? Yeah, you're not going to use 270. 270, or that's too big. You go the other way as negative what? 270 is like that. What about this way? Negative 90. Remember when sine is negative, it's quadrant 4. All right, watch the sine curve over here. Look. Will you go forwards or backwards, girls, for sine? Sine is negative 1. There. That's negative 90 or negative pi on 2. So your acute angle x is negative pi on 2. So my solution is going to be x is pi n plus negative 1 to the power of n times negative pi on 2. Instead of writing times negative pi on 2, we'll write it as pi n. Now what do I do? Plus or minus? Instead of going plus negative, you go minus negative 1 to the power of n times pi on 2. When is sine of x equal to 0? What's the acute angle? Acute angle x is, sine of what is 0? 0. So x is pi n plus negative 1 to the power of n times 0. Do you need that last bit or not? So x is pi n. Let's see if this makes sense. Here's my sine curve. let's look at what n is. When n is 0, sine of 0 is 0. When n is 1, sine of pi is 0. When n is 2, sine of 2 pi is 0. Do you see? When n is negative 1, sine of negative pi is 0. So the general solution for sine of x is 0 is pi n. Now we're going to do the same for cos curve. A quick sketch gives you your first angle, like your acute angle. What acute angle are you going to use? Acute angle x is, 0. So therefore x is 2 pi n plus or minus 0, which is just 2 pi n. Again, cos of x is 0. You can see where your first solution is. Where is it? At where? So there's the cos curve. Where is your first solution for cos of x is 0? Pi on 2. So your solution is x is 2 pi n plus or minus pi on 2. Which is 2 pi n plus pi on 2, 2 pi n minus pi on 2. Again, you can still see your cos curve there. Where's your first solution for negative 1? Yep, and that's fine. You don't, pi still takes precedence over negative pi. So x is 2 pi n plus or minus pi. Actually, this one you should, that's fine. You don't break it up. So it'll be 2 pi n plus pi, 2 pi n minus pi. Aha. What are you going to do with the next one? Just the same again. Acute angle x will be pi. So we just get that 2x is 2 pi n plus or minus pi. And we just divide by 2. So x is pi n plus or minus pi on 2. I think we've covered every possibility just about. Of x on 2 is 1. All right. What's your acute angle? There's the cos curve. Acute angle x on 2 is 0. So the solution is x on 2 is 2 pi n plus or minus 0. So what does x equal? 4 pi n. You're multiplying by 2, not dividing. Next one, tan. Tan of what is 0? Try it. Tan of 0 is 0. Acute angle x is 0. So x is pi n plus 0, which is just pi n. Let's see why that one works. So you've got 0, pi on 2, 180. This is the tan curve, ladies. Here's the tan curve. You've got asymptotes. At every pi on 2, every 180 degrees you get an asymptote, but the first one starts at, the first tan 90 is undefined. So that's what your tan curve looks like. Let's see why this solution works. See, when n is 0, x is 0. When n is 1, you get pi. The next one will be at 2 pi. And the last question. No, it's not. The second last. Tan of 2x minus pi on 6 is 0. Off you go. What's your acute angle x? Acute angle x is 0. So we go x is, no, not x. 2x minus pi on 6 is pi n plus 0. Are we all good? 2x is pi n plus pi on 6. So x is pi on 2n plus pi on 12. And the last one. So sometimes you can see the question's written like this. You know what I would do if I were you? Just rewrite the question. What's sine of 90, girls? 1. So the acute angle's actually given to you there. That's the acute angle. So when they write it like this, the acute angle's actually given to you, because if I do a quick sketch, the sine of 90 is 1. Do you see? So how do I write my solution for sine? 3x is, do you remember the solution? Isn't this one 180n plus, so it's pi n plus negative 1 to the power of n times pi on 2. Are we okay with that? Pi on 3n plus negative 1 to the power of n times pi on 6. And that's what x is.